What's up, everyone? Let's practice our binary digit flashcards with spaced repetition in Rem. So first question, what is the number 8 in the binary number system? So the number 8 in the binary number system, if we look at all the place values, we're going to have a 1 in the 8's place, 0 in the 4's place, 0 in the 2's place, and 0 in the 1's place. So that's just going to be the number 1000, 1000, or we could have 0, 1000, or any of these, just adding a 0 onto the place value to the left to create a full 8 digits or a byte of information. So we have the bit 1000. What is the number 7 in the binary number system? So this one's very, very similar. This one's going to be a 1 in the 4's place, a 1 in the 2's place, and a 1 in the 1's place in order to create 7 over here. So 1, 1, 1, we have 4's place, 2's place, 1's place, and we have 4 plus 2 plus 1 is equal to 7 over here. Why is the number 110 the number 6 in binary? Well, we have over here 4 for the 4's place. We have 1 for the 2's place and 0 for the 1's place. So 4 plus 2 plus 0 is equal to 6 over here. So we have 4 times 1, 2 times 1, and 1 times 0. Adding them up, 4 plus 2 plus 0 is equal to 6. What is the number 6 in the binary number system? So the number 6 in the binary number system is going to be, as we had just seen over here, we have 1 in the 4's place, 1 in the 2's place, 0 in the 1's place. So we have 1, 1, 0 over here. Why is the number 123 the number 123? And the reason for that is that we have 100 plus 20 plus 3, or 1 times 100. Then we have 10 times 2, and then 1 times 3 over here. So those the hundreds, tens, and ones placeholders in the binary in the decimal number system. So this is decimal, which is where this comes from, the idea of place values. So of the place values, we have hundreds, tens, and ones. 100 times 1, 10 times 2, 1 times 3. Add them up, we get 123. What are the place values in the binary number system for a byte of information? So there's 8 of them in total. We start with 128, 64, 32. We have 16, 8, 4, 2, and then 1 over here. And those can all be represented easily with light bulbs over here. So the 128th place, 64th place, 32, 16, 8, 4, and 2. So the number 128 in this case would be 1, 0, 0, 0, 0, 0, 0. In other words, this is the only light bulb that's on. Or 127, which would be 0. This one's off, it's too big. And then I would have all of these on. And if we were to add 64 plus 32 plus 16 plus 8 plus 4 plus 2, we're going to get 127 over here. So all of those would need to be on, as well as the ones place, which I have forgotten to add, which I will need to go back and add. So as well as the 1, that's what's going to get the 27. All right, what is the number 5 in the binary number system? So 5 is going to have the 4's place on and the 1's place on over here. So that's going to be 4 on, 2 off, 1 on. So that's going to be 4 plus 1, which is 5. What is number 3? That's going to have the 2's place on and the 1's place on. So that's just going to be 1, 1 over here, or 0, 1, 1. What is the smallest unit of memory size? The absolute smallest is a single bit of data. The number 4 in the binary number system is going to just have the 4's place on. So that's going to be over here 100. What is the number 1 in the binary number system? Well, that's just the first digit over there. So we're just going to have just 0, 1, or just 1 in the first one. So 0, 1. Bit stands for, it's a condensed version of the word binary digit over here. So binary digit, if it's condensed, creates BIT bits. The number 2 in the binary number system is just going to be 10 over here. The 2 is on and the 1 is off. Why is the number 101 the number 5 in binary? Well, that's because we have the 1's place as a 1, 0, the 2's place is off, and then we have the 4's place on, so 4 plus 1 is equal to 5 over here. What is a byte? It is a group of 8 bits, and it can be represented as a total of 8 digits, usually operated as a unit, and it's a unit of memory size. If you add up all of the different bytes of information all the way from 1 to 128, you can find out how much memory that is. The second smallest unit of memory size is as we just said, it is a byte over here, and 8 bits make up a single byte of data. A bit is a binary digits. A byte is a group of 8 bits, usually operated on as units. In order to create the number 8 in binary, which is 1000, we need to add a place value to the number of blank of the previous number, of the left of the previous number. So the left, we add that place value. So that would be, for the number 7, we added another place value in order to create this number 8 over here. A single bit can be represented at 0, which stands for, well, it stands for off, or a 1, which stands for on, using electricity. So a 0 is off and a 1 is on. And the opposite, a 1 stands for on, while 0 stands for off over here. I have to close those, so it's one question. And those are our 21 cards on binary digits of what you guys should have done so far. So rewatch this as many times as you need, and that is using RemNote, using virtual flashcards. Hope you guys enjoyed.